Hi everyone, we are going to talk about perpendicular lines. So this is our second video in the parallel and perpendicular lines section. Sorry, my camera is a little funky and it still kind of is. We are going to deal with it. But either way, we are going to talk about perpendicular lines. So perpendicular lines, if you played through the Desmos lesson and you got out of it what I hope you got out of it, is you would find that the slopes, when you multiply them together, equal -1 after you sort of simplify them. In other words, they are what's called negative reciprocals of each other. The y-intercept, you should have found, doesn't matter. It doesn't matter if you change the y-intercept. It's all about the slopes with perpendicular lines. So let's look at a couple of examples. Here we go. So which lines are perpendicular? We have four sets of lines. Let's look at them and see what we got here. I'm going to graph all of these. And hopefully, as we graph them, we will find ones that are perpendicular to each other. So x is equal to -2. If we remember the Hoivux lesson, you should see this x and instantly say, okay, there's no slope, there's no y in here, so therefore it is a horizontal or vertical line. This one starts with x, so that means it's vux. That means it's a vertical line and it has an undefined slope, and it goes through x is equal to -2. So I'm going to find -2 on my x-axis, and I'm going to draw a vertical line. After I draw that vertical line, I feel solid about that. Now let's think about this. Horizontal and vertical lines. If we think about those, a horizontal line versus a vertical line is automatically at a 90-degree angle. So if I have a hoi line, so a line that goes through a y, then I automatically have a perpendicular line. So if I look at this next one, y equals 1, that is a hoi line, meaning it is a horizontal line with a 0 slope, and it goes through the y-axis. So this one is y equals 1. I'm going to plot y equals 1 on here, and I'm going to draw a line through that point, and it's going to be horizontal. When I do that, I automatically have a 90-degree angle. That means that this vertical line and this horizontal line are perpendicular. So these two are perpendicular. So I'm going to show that right, just like this, a little right angle, okay? Now let's look at these next ones. If we look at these next ones, I have y equals -4x. This is written in slope-intercept form. That's awesome. That means I can graph it pretty easily. If I look at this, I have a y-intercept of 0, so it's going through 0, 0 on my graph. And then -4 is my slope, so that means I have a rise or a drop of -4. I'm going to the right 1. So I'm going to graph that. 1, 2, 3, 4 to the right 1. 1, 2, 3, 4 to the right 1. I'm going to do the same thing in the other direction. 1, 2, 3, 4 to the right 1. 1, 2, 3, 4 to the right 1. And so now I can connect these dots. Oops, and of course I did it so horrendously. Sorry. They're just going to be a little wonky. We're going to just deal with it. If I look at this next one is in point slope form. So I have to play around with it a little bit just to make sure I know where it starts. I don't need to know the y-intercept. Remember, when we have point slope form, we're given a point and we have slope, so therefore we should be able to graph it. So my point is a -1. My y is -2 in that point. So now I can graph this and say -1, -2, or sorry, -1, -2. Let's get this right. -1 on the x, down 2 on the y is right there. And then I'm going to graph this point, or this slope of 1/4. So I'm going to go up 4 and over to the right, or up 1, over to the right 4. Up 1, 1, 2, 3, 4. Up 1, 1, 2, 3, 4. And I can do the same thing in the other direction. Down 1, 1, 2, 3, 4. Down 1, 1, 2, 3, 4. And I can start to graph this line. And as I graph that line, if I look at that orange line versus the pink line, and remember my orange line is a little fudged, I kind of screwed it up down here, it clearly has that right angle. If we also wanted to look and like really dissect the slopes, we could look at the slopes. We have -4 versus 1/4. If we took that -4 and multiplied it by 1/4, 1/4 of -4 is -1. So therefore, based on this first concept, slopes equal -1 when multiplied. So I just multiplied the slopes together and I got -1 out of them. Now, what if we didn't have a graph? Let's look at this. We just have equations. We don't have a graph. Let's find which lines are perpendicular. All right, so we've talked about Hooyvaks already. I see two lines that fit that pattern of Hooyvaks. This one is a Hooy line, so it's a horizontal line with 0 slope, and it goes through the y-axis. This line over here is a Vux line. It's a vertical line that has an undefined slope and goes through the x-axis. So looking at those two, if I have a horizontal and a vertical line, they are perpendicular. They meet at a 90-degree angle. So these two lines here, we can say these two lines are perpendicular. They meet at a right angle. Let's see if these next two lines are also similar to that. So if we look at this next one, this is written in point-slope form. Remember, point-slope form looks like y minus y1 is equal to m minus x1. So if I look at this, my slope is 5. My slope is 5. If I look at this one, I have this one in y equals mx plus b form. So my slope here is -1/5. 5 times -1/5. Well, first one is 1/5 of 5. That's 1. And it's negative. That means my answer is -1. Awesome. So we can now say these two lines as well are perpendicular. Notice I'm not worried about the y-intercept on any of these, except for this one because it is a y-intercept. I'm not really worried about the y-intercept on any of these because y-intercept does not matter with perpendicular lines. Thank you for watching. We have one more video after this one. When we are finished with that video, we will be able to start working on our must-do practice problems. Bye.